LeChatelier's principle. LeChatelier was a French guy studying equilibrium stuff. And in an industrial sense, if you have a very small KEQ, that means it's very difficult to make any product. So you get very little product, and you waste a lot of the reactants. It's not very effective. So you make very little product, and you have an overabundance of reactants. So what he did was he studied how you can make more products. LeChatelier's principle definition. When a stress is put on an equilibrium, the equilibrium will shift to relieve that stress. If the ratio of products over reactants is disturbed, if you do something to it, it's going to have to shift to relieve that stress. If the ratio is, say, supposed to be 1 to 2, but you put in more reactants to keep that 1 to 2 ratio, you're going to have to decrease some of this and make more of this until it gets to be equilibrium, which would be 1.5. So this would be 1.5 over 3, which is still 1 to 2. So the equilibrium shifts. So you put in a whole lot more product or reactants. Let's do that over again. So if you have 1 to 2 ratio is what you want, and you disturb it and you put in 1 over 4, so if you double the number of reactants, that's not 1/2. So some of the products is going to make, some of the reactants are going to make products, and you're going to get something like 1.5 to 3 ratio, which is in equilibrium. So that's the numbers of it. What are things you can do to stress the system? You can change the concentrations. You can add more products, or you can add more reactants. You can remove product, or you can remove reactant. Let's do N2 plus 3H2 in equilibrium to NH3, all gases. So if you add to this side, it's going to shift to the right. If you add NH3, it's going to shift to the left because that's too big. It's going to shift to left. So this is all going to be about shift right, shift left. If you remove NH3, that means this side's too small, so it's going to shift right. If you remove either the N2 or the H2, you're going to shift to left. You can change the volume and or pressure. So these are the concentrations. Pressure or volume if it is a gas. Only the gas particles matter. If there's a solid or a liquid or aqueous, none of those matters. It's only the gases that matter. And you're going to, if you increase the pressure, the equilibrium will shift to the smaller number of gas particles. So what you do is you count how many gas particles you have on each side. If you decrease the pressure, you're not squeezing anymore, you're allowing it to expand, and so the gases want to spread out as much as you do. If that happens, then you go to a larger number of gas particles. And that's on the end. So if you increase the pressure, which is decreasing the volume, you're squeezing it. If you decrease the pressure, which is increasing the volume, then expand. Either one of those will do it. So for our example up above, there are 4 gas particles, 1 N2 and 3 H2. On this side there is 2. So if you increase the pressure or decrease the volume, you're going to squeeze it to the side with less things, so it's going to shift right. One common misnomer, you are increasing the pressure on both sides. They're all in the same container. You have a container with N2, H2, and NH3. All of them are in there. And then if you squeeze it, you're not just squeezing the left-hand side of the equilibrium. It affects the left-hand side more than the right-hand side. But that's what, please don't say, if you increase the pressure on the left-hand side of the equation. Don't do that. Bad. And reverse, if you decrease the pressure on this example, which means you're increasing the volume, it will shift left. You can change temperature. You can find if it's exothermic or endothermic. You can treat heat as a product which means it's producing heat. That means it's exo. Heat is a reactant if it's endo. So up above you can rewrite it N2 plus 3H2 in equilibrium with 2NH3 plus heat. That would be an example of an exothermic, or you can just write down exothermic, or you can write down a negative delta H of some sort. 3 different ways of expressing that. Now, if you increase the heat in this example, increase the temperature, it affects the right-hand side more. It's too big, so it'll shift left. If you decrease the temperature, that means you're removing some of the heat, and it will shift right. And the opposite would be, if it was an endothermic, heat would be on this side if it was endothermic, and it would be the opposite. If you increase the heat, it will shift right. If you decrease the heat or temperature, it will shift left. there are some things you can do that will have no effect. For the equation that we've been working with, N2 plus 3H2 equilibrium 2NH3 plus heat, if I throw in some oxygen's not involved. Nothing's going to happen. If it's not a substance that's involved in the reaction, actually nothing happens. Even if it increases the pressure, it's not going to increase the reaction one way or the other. If you add a catalyst, so one thing that have no effect is add something not involved. You can add a catalyst. A catalyst will enable it to get to equilibrium quicker, but increases the rate both ways. So a catalyst does nothing, it just gets equilibrium quicker. So that's all there is on that. That's the end of this lesson.